Hello students, welcome to online classes, class 12 physics, and our today's topic is eddy current. Okay, what is eddy current? It is a type of induced current only. So you need to know what is induced current. You have known induced current, we have studied in our previous lecture. Okay, we will very fast revise it. Induced current is given by Faraday's law. And what is induced current? Suppose there is a coil and we keep a magnet over here. If we move the magnet in either of the direction, then the magnetic field lines, or you can say flux linked with the coil, changes. Magnetic field lines or the flux that is linked with the coil changes if the magnet is moved in either direction. If the magnetic flux line changes, then there will be induced EMF in it. There will be induced EMF in the coil, and if we attach it to a circuit, then there will be induced current also inside it. Okay, so based on this formula only, suppose we have a plate instead of coil. If we have a plate, and if this plate cuts the magnetic field lines, or there is change in magnetic field lines, then what will happen? There will also be a current induced inside it, and the current will be in the form of circles, or you can say in the form of eddies. Due to this shape of this current, or you can say eddies, it is generally known as eddy current. So a current that is induced in a plate, like suppose this is a plate, and if this cuts any magnetic field lines, or there is change in flux, then it will induce some current, and that current will be in the form of this eddies, and this is known as your eddy current. Okay, now we will be moving towards the second topic, that is what is the effect of eddy current. So to know the effect of eddy current, to understand what is the effect of eddy current, suppose there are two magnets. Let us say name North Pole and South Pole. So there will be magnetic field lines going from one pole to another pole, and we keep a suspending plate from a fixed support, a suspending plate. If that plate is suspended in a form of a pendulum, then what will do? It will cut the magnetic field line. Suppose these are my two magnets. This is one magnet, this is second magnet. If this is a magnet and I have suspended a plate over here, and it moves like a pendulum. Okay, if it moves like a pendulum, what it will do? It will cut the magnetic field lines in between. So what will happen? When it will cut the magnetic field lines, there will be some amount of current induced in it, induced due to induced EMF. So what will happen? If suppose the pendulum is moving in this direction, what it will do, in absence of any external field or any external force, it will take some time to, if I have given a rotation from over here, it will take some time to reach on the stable position. Suppose in absence of magnetic field, it takes 20 seconds. It takes 20 seconds to reach to a stable position. Suppose I have given a rotation like this to a pendulum, it will rotate this way, and it will come at the center and come to stable. For that stabling time, it is taking 20 seconds. Now if I apply the magnets, if I keep the magnets and then allow this rotation, it will come to rest in a very small, in presence of magnetic field. It will come to rest in only 5 seconds. Or you can say 2 seconds, it may be 3 seconds, it may be 4 seconds, but it is always less than 20 seconds. Why? Because of the induced current. What is induced current and what is the direction of induced current? For that you need to revise Lenz's law. What does the Lenz's law say? Lenz's law says that the direction of induced current is always in the direction opposite to the cause that is producing it. Here, why the induced current is being created? Because of the motion of the pendulum. Because of the motion of this plate, there is induced EMF because it is cutting the field lines. So what this induced EMF will do? It will try to bring this thing in stable position so that it cannot cut the lines or cannot cut the flux lines. So in presence of that, what will happen? It will be opposed, so it will come to rest in very small time, that is say 5 seconds, it may be 2 seconds, it may be 6 seconds or anything, but it will be always be less than 20 seconds. Okay, I hope this is clear. Then how to reduce the eddy current? How to reduce the eddy current? Because of this eddy current, heat loss, one topic was missed. What is heat loss? Due to this eddy current, there is current moving in the circuit. So we know that power output or heat generation is given by equation I square R. So more the current is created, there will be more amount of heat. Due to that heat, it may damage the materials or it may damage the products. So this is generally of no use. Generally eddy current are created by themselves and that they are wasting the material or it is hurting the material. Okay. So due to this I square, due to this induced current, there is a heating process that takes place. So due to that, there will be heat loss in each and every material. Okay. Next, how to reduce the effect of eddy current? How to reduce the effect of eddy current? Here, if you want to reduce the effect of eddy current, only thing is you can increase the value of R. If you increase the value of R, automatically the value of I will decrease. If the value of I will decrease, what will happen? I square will also get down. So what you can do? R is proportional to L by A. So to increase R, what you will do? You can decrease the area. If you decrease the area, R will increase because it is inversely proportional. So instead of, suppose this was a normal plate, you can use a different plate with like some holes. You can use this. What is happening? Here the area is reduced. So if area is reduced, the resistance will increase. Not necessary that only this shape, it can be of any shape. Just you need to reduce the area. If you reduce the area, the resistance will increase, and as the resistance will increase, I square will decrease. Okay. So due to that, the losses in the material will decrease or the heat loss will decrease. Okay. Next is the uses of eddy current. What are the uses of eddy current? So first one is magnetic damping. Okay, what is magnetic damping? Magnetic damping means reduction in the amplitude. What is amplitude? Suppose this was the pendulum. What was the amplitude? Amplitude is the farthest point. Okay. So if this was the amplitude of this pendulum, then what is a magnetic damping doing? It reduces the amplitude. It reduces the amplitude. So here in this case, this was the same thing that was happening. What it does? It damps the system so that the amplitude becomes less. If initially it was moving in this manner, it will try to stop it. It will try to stop it. That is magnetic damping. So first is magnetic damping. Second is magnetic damping. First one is magnetic braking. Okay. Suppose these are rails. There is a wheel over here and there is an electromagnet kept over here. Now whenever the braking has to be applied, what it does? Here in this electromagnets get activated, or it is activated using a switch. As and when this electromagnet gets activated, this wheel over here keeps on rolling. So when it keeps on rolling, it will continuously cut the magnetic field lines. It will continuously cut the magnetic field lines that are coming from this magnet. So what it will do? There will be induced EMF or induced current in it. And what the Lenz's law says? That it tries to oppose the cause that is producing it. Because of this motion, induced current is being produced. So what it will try to do? It will try to oppose the motion and it will try to stop it. So there will be a braking system applied to this system. So this can work as an additional braking system in, generally they are used in railways. Okay. Next is induction furnace. What is induction furnace? Induction furnace uses the principle of this, that is heat. Okay. As in when you increase the current, if there is more current, then there will be more heat. So this heat is used to melt the metal in the furnaces. In the furnaces, generally the current is given very high, or eddy current, very high eddy current is produced, due to which there will be very high amount of heating, and that will be used inside the furnace to melt the metals. And the last one is electric power meters. You might have seen at your home there are meters, electric meters. In that there is a shining dish that is rotating all around. That is due to eddy current. Due to varying current that comes in our house and eddy current produced inside it, Due to that eddy current, your disc inside the meter keeps on moving. So it shows the amount of eddy current produced, or it shows the amount of electricity that is used inside your home. So that disc works on eddy current. Okay. I hope the topic of eddy current is very clear to you. So till then, students, keep studying. Have a nice day. All the best.